Good evening. I'm Bruno Bonanno. The name in the slide doesn't match with what we published because this is a modification of a presentation I did for a Java conference. So I'm going to skip the loosey explanations for Java developers and get into more interesting features. But the idea is I'm going to show, so the cryptocurrency algorithmic trading is just because that's what I do at work right now and because I think it's interesting. And also because probably for a lot of people this is something that is not well known or not known at all. And the whole point of this talk is to introduce a way or a set of tools so we can write tests that can be understood by any person that is not technical or technical persons that are not necessarily into the domain. So this is because I just wrote this. I don't know if someone said it before, but the whole point is that we could have a lot of tests that run and they are green and they are fast and they are amazing. But the fact that they are green do not necessarily know that we implemented what the business wanted. And as an application developer, that's what they pay me to do. I need to deliver what they want. And in the scenario of algorithmic trading, if you do it wrong, if you do it wrong, you can lose a lot of money. You can even crash the market sometimes. So it is important that we can talk with the VAs or with the traders and they can understand what we are talking about. And also traders are always in a rush, so they need to be able to say, yeah, that's what I want, or no, this is wrong, please fix that. And for that we also need a unified language, so they don't want to learn about our coding terms, we don't want to learn about, well, we more or less have to learn about the stuff, but the idea is how can we make the code to be written in a way that they can understand without resorting to stuff like Cucumber and having strings that have to be parsed and then have to, the fact that the string says I do blah doesn't necessarily mean that the code that that string is implementing does blah. So I had a couple of bad experiences with that. So yeah, that's me, if you didn't get it yet. Yeah, I'm pretty big on testing. I really like TDD and BDD. I created the Scala version of Mockito because I thought that using the Java one was quite hard and putting people off of writing better tests. So check it out in GitHub if you have a time. I'm going to be speaking about that in a follow-up meetup. So what I'm going to talk today is, again, because this is a problem that not necessarily everyone is familiar with, I'm going to introduce a few financial concepts. I'm going to introduce the use case, and then we'll see some code. So to start with, this is a master book. This is a market book. This is a snapshot of Bitcoin because before it reached like 12K yesterday or something. It's getting crazy. But what this is like, this is telling me people that want to buy Bitcoin and they are willing to pay this much or this much or this much. And this is how many Bitcoins they are willing to buy at that price. And the ask is completely the opposite. Those are people willing to sell Bitcoin, and so they are asking dollars, in this case, in exchange. And so they expect to get that much for each Bitcoin, and that's how many Bitcoins we can get. And as you can see, the prices, the asks are always higher than the bids, because otherwise the market would have made a match and they wouldn't be there. And this is a very basic diagram of what an order management system is, which is a piece of software that will be connected with one or more exchanges. It's going to look at this market data, which is basically these market books changing all the time. And it's going to react based on some conditions we will program. And it will execute some actions in the same markets or maybe in different markets, and it has to coordinate all of that. So the complexity explodes immediately. maybe looks simple, but it's a really hard problem to solve. So, and also, it's outside of this talk, but each exchange in the crypto land, they are not standardized, so you have different APIs, threads here, WebSocket here, fix over there. It's crazy. So applying a good set of tests over here is essential. And so the example we will be working with is this Jira ticket that, so we want to implement a feature for doing triangular arbitrage in our MS. So a triangular arbitrage means that by buying or selling in 3 different places, we can end up with more money than what we started with. So let's say we have $10,000. If we go and buy in some market, so the thing is getting market data now. So in this example, if Bitcoin is at this price in some market, given that we have $10,000, we can get 1.27 Bitcoin, which means that we can then go and buy Ethereum with that Bitcoin and get 42.33. And because in a different market that Ethereum is at a non-level price, if we sell it back for dollars, we will end up with about $600 more. This is, of course, if this was so easy, I wouldn't be here, I would be making money at home. But this is actually real. This is what banks and hedge funds do with much bigger amounts and much smaller margins. So they would be making like cents on each transaction or each unit of currency. But this is how global markets stay level, and that's why the price of Euro USD in Japan is the same as the price of Euro USD in the US and in Europe and everywhere. Because as soon as there is a discrepancy, there will be a computer saying, oh, I can buy here, sell there, blah, 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 boom. And so because these computers start buying and selling, the market reacts and the prices go down or high if we are buying or selling. It's basic offer and demand. But yeah, this is basically what we will be implementing today. Any doubts so far? We are good with this? Cool. So yeah, this is basically the challenges with all developers. So we understand that a lot of things can go wrong with the APIs. We also have to take consideration of rounding, because if we sell the wrong precision to the exchanges, our order may come back. We don't want to buy too much of anything because we may lose money and the markets may not. So the fact that we say we want to buy something doesn't mean that we will get it. Otherwise, the market wouldn't exist. So our order may not be filled because someone else bought something before ourselves, or we may get part of the order, and what do we do? So there are many things that can go wrong, or not necessarily wrong, and they are actually business as usual. So as a glossary, ask is the price at which we buy, because we pay what someone else is asking for. The opposite, we bid. When we bid, it's because we are selling. An order is what a message we send to the exchange to say, give me this much of Bitcoin, given that I'm willing to pay this price. And a market report is the report of what happened with that order. Was it successful? Was it not? Did I get half of it or whatever? So yeah, we are on the same page. And yeah, now is where everything can go wrong for me. So let's see what we can do. So I have this test. The microphone is breaking, right? Something. Yeah. Good. So I have this test that I've been working on, and it's a functional test, and something I didn't mention before, but most of the financial systems work in a message-based, single-threaded way. So let's say like an ACA actor. We use ACA for that, but it helps with the example. So basically here we have an instance of our MS. We'll simulate some connector to an exchange with a mock, and basically, given we have $10,000, as we said, these are the master books we have in the market, and these are the orders we expect to send, the first order at least, and we'll get a market report, and then we have another order, another market report, and so on, until we should end up with our money. Now, the problem I see with this test is that if I want to get a BA or a trader, he will not get it. I mean, yeah, we say this is a quantity and this is $10,000, and if you really look at it, it may make sense, but for a non-technical person that has his mind in something else, it may be challenging. And the good thing with Scala is that we can do better. So something that is really simple and it helps a lot is that here we are constructing a currency pair, so basically for BTC USD. But if you look at any blotter or any UI that a trader will use, they will just see like either BTC USD altogether or maybe with a slash in the middle. So what we could do then is to say, okay, if we have a currency, and this is going to be useful in our code base, so I'm going to do it in production code, we could just have a method that given a currency and another currency, returns a currency pair, right? So the cool thing about this is that for our users, we can go and change all this nonsense sorry, I don't want to delete more parentheses than necessary. I mean, this is not rocket science, right? We all know that we can create methods with funky names in Scala. We just saw it in but this is the thing. We can use the power and flexibility that Scala gives us to do good or to do bad. So like Uncle Ben said, great power, great responsibility. So let's be Spider-Man. Another thing that would be nice is, can we just say $10,000? Yes, we can, because in Scala we have implicit classes. So why don't we just say that we have a class that is our number ops and yeah, so in this example I'm working with 3 currencies, so I'm going to create them. And the other thing I'm doing is I'm creating this class in test code, because first of all, this is not something I'm going to do in production. And second, it's kind of not necessarily super cool to be creating methods like this. But because it's for the sake of testing and it's a DSL, it's fine. So here we will say that if this is like this, then we will create a quantity where the quantity is that, and then we have Bitcoin. And of course, we'll do that for all the others. So I'm going to cheat now because I'm lazy. And I have a regex already that does it for me because reasons. So there you go. And I brought something. Yes, because that was the output of a different regex. Don't worry. Intelligence is nice. So yeah, so now we can say something like, we actually have $10,000, we have 10 Bitcoin, is quite more readable. Now, I would like to do something with the price, but with the price is slightly different, because what normally happens is that you have something at a given price, and here all my methods, they expect 2 parameters. So before doing any more modifications, I'm going to basically fix this test in a different way. So something that is not necessarily wrong, but I consider a bad practice in testing is that constructing our business objects directly is always a reason for future pain, because if we add more fields, we don't want to modify all the tests. We may have a default value, and we may have default values that do not make sense in production, but do make sense for testing, because our testings, they should be consistent, so our default currency pair is always BTC USD or something. So having a test builder is well, it's a test factory, but I used to build test builders in Java, and I stick with the name. So again, I cheat, and I have a test builder more or less ready here. So I have a test builder that takes an order and a price level. So the only thing I need to do is to mix in this trade. And so now I can go and replace all my price levels by the lowercase, and even my orders by the lowercase. Now, the cool thing is that now that I have a test builder, I can change the signature. So basically what we want here, as I said, is it would be nice to write 10 Bitcoin at this price, right? And this price is basically $7,900, so it's another quantity. So I just need something that goes from quantity to quantity. So, and again, this is test code, so we can have another implicit class that is quantity ops. And then we can have a method called at that given another price, which is a quantity. Let's cheat a bit. This will return a tuple of the quantity we want and the price we want. So what do we want? Well, the quantity is going to be the quantity we already have, and the price is going to be the value of this price. So for the record, a quantity is a value and a currency, and a price is a value and a currency pair. So cool, now we have this price, and now we need a currency pair. And what is a currency pair? Well, is the currency of the first quantity we have, and we have our nice slash here, and then the currency of the price, right? So this means that I can write something like at this many dollars, and it just works. Well, it doesn't, because my method still expects for a quantity and a price, not a tuple. But the cool thing of using a test builder is that we can just change our signature and then say, okay, we actually expect this to be blah. Am I going too fast? Everyone is all right? Cool. And now that works. And again, I have a regex that does that for all the replacement for me because I am lazy. Come on. Okay, it doesn't want to work because reasons. This is where the library goes wrong. Whatever, let's do it by hand.
Because you already did the currency. Because you already did the currency.
Change the currency pair to the slash thing.
Yeah, regex is searching for currency.
Oh, yes. Okay. That's a good one. What are you doing, IntelliJ? So if we remove this and we have the slash, yay, that works. Thank you. it doesn't work because I hit up an extra parameter, an extra parenthesis. Yes, cool. Yes. That was a meme. It's very accurate, but ooh. Oh, damn it. Bear with me. I'll fix it. I hope. Okay, you need an extra parenthesis, you need an extra parenthesis. You also need an extra parenthesis, I guess, and you too. Don't be jealous. You go on the same line now, which means that we can write all of this on the same line, which is good. And of course, the compiler doesn't like it now because here we need a parenthesis, and the order is still looking for a quantity and a price, so let's change that. Okay. Market report, you don't like it, I don't care. So now, the next thing I want to fix before fixing this is that, so we kind of know that this is an event-driven system, but our product owner doesn't really care. And this OMS on message is like, whatever. So let's make that more readable. So again, I have this kind of thing ready. So I have a test DSL that will hide that for me. And the thing is, what we need is to be able to send this message or any kind of message into our OMS. Now the problem is that we don't have an instance of that, and we don't want to be passing it either because that would pollute our nice DSL. So let's make it implicit. So if we were to take an instance, lowercase please. So now, why is it not working? Yes, because you're unique. Sorry, I had this in the test builder before. Reasons. So if we were to take all these parameters implicitly and merge these back in our test, okay, so we can say that we set some available funds, and that then all of this becomes on. So now, I mean, we can discuss with our users here how they want to express that we do something, but at least we don't have all the extra complexity of the OMS. I send a message, they don't care, and we shouldn't care either. And because now we have this nice trait, let's move our implicits over here so they don't pollute our code. This is failing because, again, I cheat, and one cool thing that we can do when we have our DSL is like, who cares about having a sequence when we can now have varchars? And the other problem I see here is that if you remember the example, we only care about the first two ask prices and the bid price on the last market book. So the thing is, first of all, I don't know what is what here. So I could easily use name parameters for that. But the reason I had all of this is because to construct our objects, we need to pass something or an empty sequence, which is also nonsense. But when we have a test DSL, we can have defaults that make sense for the test. And I wouldn't want to have that in production because I don't want an empty market book. But in test, it makes complete sense. So I can go and remove this thing from here, this thing from here, and this thing from here, and then all of this becomes basically one liner, which is amazing. And let's clarify what are we talking about. Yeah, this comma doesn't belong here. And so in our market report, we also have this quantity and price thing. So I'm going to borrow that from the test builder. So I hope that by now you kind of see how I mean, I'm not doing anything crazy here. I'm not doing anything more than using basic Scala so far. Well, you have a couple of implicits and stuff, but it's nothing super crazy. But it's something that in like 10 minutes or something, I'm going over time already. Oops. Okay. So by just doing some simple tricks and using the tools we have at our disposal for the good, and not to create cryptic symbolic thingies, we can have tests that actually represent what the user wants. And I still have a lot of changes that I wanted to show, but I guess pizza comes first. Is the pizza around already? Is the pizza here?
No.
Yeah? Okay. Then the pizza guy is the one that will take me out of here. So let's run the test and you. I never remember what. Yes, you. Let's run the test and see what happens. So we have a fail because this is saying that. Okay, so this is Mockito telling me that we were expecting this order, but we got a different order, and I know in advance already that this is the problem, this tiny number here. So to start with, our orders do not make much sense from this moment, like what the heck is this one and what the heck is this one, right? And do we really need them? So if we look at the definition of order, this is an integer for the order ID, so this is how we'll identify our order with the exchange, and this is going to be in the market report, so it's important. Our market report has to have the same ID, we want to see it. And this is the book version. So this is something I added so I can take it out in the demo. But basically, we use versioning of the books, because if you send an order and the market rejects it, it means that the price you use for that order is stale, and you shouldn't try to send another order unless you have newer market data. Otherwise, your order is going to be rejected again. But for the sake of this particular test, because it's a happy path and everything, we don't care. So we could say that the default book version is 1 for everything, and we just take it out. Now, this is not going to solve the problem that Mockito is complaining about. So what we can do here, and first of all, I'm going to move out of the standard Mockito sugar that you have in Scala test, and I'm going to use idiomatic Mockito. So yeah, this is the library I write, and self-promotion, and deal with it. Actually, I'm going to use the one that is integrated with Scala test because it's nicer. And so this syntax is going to easily become something like verify that that method was called. Now, the cool thing about this syntax is that one of the things that the macro that deals with it will do is wrap any kind of argument in an equals, in a matcher equals. So this allows you to mix matchers and non-matchers. The pizza is here, so I guess you stop caring. But the other cool thing is that this equals matcher is a Scala one and relies on a type class called equality that comes with Scalactic. So if I were to go to the test DSL and define implicit val order EQ, and the cool thing is that we can override this equality just for the test and then choose which type class is in scope. So this is an equality of order. Come on. Blah, 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 blah. So here we can basically say, okay, compare everything but that last parameter, and we could have this order without book or whatever. And so Mockito is going to stop caring about that. Mockito will also use another type class which is called prettifier, also from Scalactic. So you can override a toString and print that order in a nicer way. So I like to print it in the same syntax. So rather than having, let's run the test again. Yeah, okay, fine. Be happy. This is the last thing, I promise. And it's not working. Okay, the point is, rather than just the traditional toString of the case class, which is going to look like the case class, we could, for testing purposes, just get the quantity and the price as number.currency at number.currency. So then, if we trust our implementation, you just can copy and paste from the error to the code. And that's not for the VA, but it's nice for us. And yeah, sorry, I ran out of time, but I hope you get the point. There are many things, and I'm going to finish the example and push it into a GitHub repository. So basically, there, I'm going to create another branch called Scala in the C because that's a demo for a different thing. But yeah, thank you. Sorry for the delay. The pizzas weren't here, so it's fine. Any questions? Good. Dinner time. Thank you.